let's take a look at this one, the ASCII one. I think I tried to demonstrate this last week and it didn't work, and I found the problem. There was an updated version. I was linking to the old version. So here's the greet program in assembler. Let's take a look at that. It's on here. So if I cat greet.asm, all right, and this, I just put this here to give you something to start from so you can move ahead. So here you see the data section. I've got hello, and I put a bunch of blank spaces here and line feed and carriage return. Then I have the length pointer here, which will calculate the length from above, so it'll be whatever the length of that is. Then there's a prompt and a place for your name that, again, just set aside some room. And so here, let me make this wider there so it won't wrap around so much. All right, and so here you do a write. So you write a prompt. So it's going to print out the thing called prompt, which is going to be this thing, what is your name? Then it's going to read from the user up to the length of the name. So by the way, notice it's not going to have buffer overflow, which I'm sure you'd ever have that in assembly. You specify how much to read all the time. Then I'm going to have a loop counter on length of name, starting at length of name, and this is the point. I'm going to read through those letters in the name one by one. So I'm going to load hello and then add 6 to it and put that in EDX. And then I'm going to add the length of the name. So I've added length of name plus 6. And the reason is because I'm going to add it to this string hello, comma, space. So I added 6. I'm going to write here. I'm going to write your name here, starting 6 bytes into this array, so I can reply with hello, your name. That's the idea. So it has 6 in to skip the hello, comma, and then it adds the length of the name here. So it's ready to write it. And so the point is the length of the name is limited to this, which looks like about 8 or 10 characters, and I'm going to write just those 8 or 10 characters here. And so if your name was shorter, these will just remain spaces, and when I write them here, they'll remain spaces. So that's the plan. And so now I can just copy your name into there. So here I move, I decrement ESI, and now for each character, I take a byte, I move 1 byte from ESI to AL, and this is a mistake I made earlier when doing these projects. If you don't move just 8 bits, you'll be moving 32 or 64 bits, and this is 32-bit Intel, so I'll be moving 32 bits, and then you'll keep overwriting extra characters. If you really want to copy characters one by one, you have to make an 8-bit command, which moves AL. So it's going to take 1 byte at that location and put it in AL, and then move it to this other location, which points there. So it's going to take the names from here, starting on the right, and copy them here. That's how it's going to make it, and then print that out. So that's what it does. It just says hello. So if I run it, let's do an ls to see what I got. It's greet. Okay, so if I say I'm Sam, it says hello, Sam. That's all it does. All right, so that's an example program that shows you how to read and write and how to do byte by byte copy into an array. And so once you've got that going, then you can try doing things like this. You can take 2-digit numbers and convert them into ASCII. So what you're going to have to do is take these numbers, turn them into integers. And if you look at the tutorial, the assembly language tutorial, they show you a nice way to do that. You can subtract quote 0 quote from something. I did it by subtracting 0x30, which is the ASCII code, the number for this numeral 0, but you can also use quote 0 quote. You have to take this 6 is going to be 36 in hex. So you have to take away the 30 and have the 6. Then you can do math on it. Take 6 times 10 plus 5 to calculate this number. So you have to take ASCII numbers and turn them into real numbers you can do math on by subtracting quote 0 quote from them is one way to do it. And then reconstruct the character to print out. So that's that gives you some practice. And here's a string where if you resolve all these 2-digit numbers one by one into letters, it'll give you a flag. And here's one that takes decimal numbers that can be 3 digits long, separated by commas, and turns them into printable ASCII characters. So again, you're going to have to read these digits one by one, subtract quote zero quote from them to turn them into numbers, do math on them to multiply them by 10 and 100, and then print the ASCII character that comes out. So that gives you some practice turning ASCII into numbers you can work with, and vice versa, which is an essential part of all assembly language programming, to convert stuff into machine readable numbers and then into human readable numbers. So that's all I wanted to say about that one.